Hello there! In today's video, we'll talk about energy, particularly the kinetic energy, gravitational potential energy, and the energy conservation during freefall. What is energy? Energy is the ability to do work, is a unit in joule. It is named in honor of James Prescott Joule and his experiments on the mechanical equivalent of heat. First, let us talk about the kinetic energy. Kinetic energy is the energy stored in an object because of its motion. Anything that has mass and is moving has a kinetic energy. Kinetic energy is represented by the following formula, where m is the mass of the object and v is the speed or velocity of the object. Example: let us say that we have a car of mass 1,500 kilograms. At standstill, its kinetic energy is zero for it has no motion. Using the formula of kinetic energy and substituting the following values, we get kinetic energy is equal to 1/2 times 1,500 kilograms times 0 meters per second squared and would be equal to 0 joule. If this car starts running, and let us say it has now a velocity of 50 meters per second, it would now gain a kinetic energy. Using the formula, it would be kinetic energy is equal to 1/2 times 1,500 kilograms times 50 meters per second squared and is equal to 37.5 kilojoules. Let us proceed to the gravitational potential energy. Gravitational potential energy is the energy stored in an object because of its position. The measure of an object's position is its vertical distance above a reference point. Normally, it is the Earth's surface but can be at any point. It is mathematically represented by the formula, where m is the mass of the object, g is the gravitational acceleration, and h is the height of the object relative to the reference point. The greater the height of the object to the reference point, the greater the potential energy. Example: say this is a 10-meter building and a 1 kilogram ball is placed at the top of this building. How much potential energy is stored in this ball? Using the formula, we get potential energy is equal to 1 kilogram times 9.8 meters per second squared times 10 meters and would be equal to 98 joules. Gravitational potential energy is dependent on the elevation of object above the reference point. The higher the elevation, the greater the potential energy. If we place the ball at 11 meters above the ground, its potential energy becomes greater. Placing it lower at 9 meters above the ground, its potential energy becomes lesser. Lastly is the energy conservation during freefall. In freefall, the sum of the initial potential and kinetic energy is equal to the sum of the final potential and kinetic energy, or PE1 plus KE1 is equal to PE2 plus KE2. To further understand this, we proceed to example. In the example above, we will show that at the moment of impact, the kinetic energy of the ball will be equal to the potential energy of the ball at 10 meters. At initial state, when the ball is standstill, we already calculated that the potential energy of the ball is 98 joules. And during this time, the kinetic energy is zero since the ball is not yet in motion. That is, PE1 plus KE1 is equal to 1 times 9.8 times 10 plus 1/2 times 1 times 0 squared and will be equal to 98 joules plus 0. This is for equation 1. At the final state, as the ball hits the ground, its potential energy will be equal to 0 since the height is now 0. That is, P2 plus K2 is equal to 1 times 9.8 times 0 plus K2 and will be equal to 0 plus K2. And this is for equation 2. Since PE1 plus KE1 is equal to PE2 plus KE2, it will be 98 joules plus 0 is equal to 0 plus K2. And we get K2 is equal to 98 joules. We now calculate the kinetic energy of the ball at the moment of impact. We can see that the potential energy is converted into kinetic energy as the ball is dropping, and the maximum kinetic energy is experienced just when the ball is at the moment of impact at 0 meters. If we calculate the velocity of the ball at the moment of impact, we will use the kinetic energy formula. Looking for velocity, we get V is equal to square root of 2 times kinetic energy divided by the mass, and velocity will be equal to 14 meters per second. Using the formula of potential and kinetic energy, we arrived at the following values. As the ball is dropping, its potential energy becomes lesser. The kinetic energy becomes greater because the velocity of the ball is increasing as it is approaching towards the ground. That's it for our topic of energy. Let us keep on learning. See you!